Hello, Algebra students, and welcome to another lesson. We are in section 8-2, day 2, and what I'd like for you to be able to do by the end of this unit is to calculate and identify the GCF of the terms in a polynomial and then factor it out of the expression. So factoring is going to be our next really big subject, and we are just going to be focusing on factoring the GCF out first. So what is a GCF? So a GCF is the greatest common factor. So factors are what you can break the number down into by multiplication. So we're asking ourselves, what is the biggest number that I can take out of all of my terms in a polynomial? Because it says common. So I want the biggest number that is also common between all the terms in my polynomial. So how you're going to do this is you're going to calculate whatever the GCF is, or the greatest common factor. And then when you know what that is, you're going to divide it out of each term. So in this first example, I have 4x to the fifth minus 24x cubed plus 8x. What is a number? You're asking yourself, what is a number that I can divide out of 4, 24, and 8 all at the same time? If you need to, then you can break them up into their prime factorizations. So 4 is equal to 2 times 2, and 24 is equal to 3 times 2 times 2 times 2, and then 8 is equal to 2 times 2 times 2. And you have to find what's common between these. So you want the most amount of things that are common as possible, but you cannot exceed it. So this 4 came from right here, this 24 came from right here, and this 8 came from here. And I just broke them down into their prime factorization. The way you can do that is by using a factor tree, like when we had 4, that breaks down into 2 and 2, like that. I just didn't do all the factor trees here. So now we're saying, okay, what does this have in common, this have in common, and this have in common? Well, this guy has 2 2's, this guy has 2 2's, and this guy has 2 2's. So I now know I can take 2 times 2, or 4, out of each of these terms. So that's the most that I can do. I can't take more because there's nothing else that they have in common or that they share between the terms. So I'm going to pull a 4 out, and I'm going to write it down up front. And then I'm going to look at my variables. I have x to the fifth, x cubed, and x. So if I were to expand all of those, you'd ask yourselves, how many x's do all three terms have in common? How many x's do they have the same amount of in that sense? This one has 1x being multiplied. This one has 3 x's being multiplied together, and this one has 5 x's being multiplied together. The most that I can take out of each of them is just 1x. So I'm going to pull 4x out. Now I'm going to write a parenthesis. I found my GCF. 4x is the GCF. Now I'm going to divide that out of each term. So 4 divided by 4 is 1. X to the fifth divided by x is x to the fourth. Remember, I'm subtracting exponents because I'm dividing. Okay, now I have a minus sign, and I have negative 24 divided by 4. Well, that is going to get me 6. And then x cubed divided by x is x squared, plus 8x divided by 4x is going to get me 2, because 8 divided by 4 is 2, and x divided by x cancels itself out. So this is my final answer, 4x parenthesis x to the fourth minus 6x squared plus 2. Okay, we're going to do that, we're going to do that some more. So in these next examples, we're just going to factor out the GCF of each term. These are my two terms, or each polynomial. I'm asking myself, what do they have in common? Well, this coefficient is 2, and this coefficient is 1. So the most I can divide out as far as the numbers go is 1. This one has x squared and this one has x. How many x's do they have in common? They have one x in common. So I'm going to pull that x out to the front. Now, I'm dividing this x out of each term. This is the distributive property backwards. I'm actually going to put that up here just to help you out. So, distributive property backwards. Basically, that's what we're doing. So if I pull this x out, I have 2 still remaining. And if I pull an x out of x squared, I still have an x. If I pull, and then I got my minus sign. If I take x divided by x, that is just 1. And there I'm done. Let's do e next, just because it's a little bit simpler. So I have 5x squared plus 15x plus 10. Looking at my numbers, 5, 15, and 10, what is a number that I can divide evenly out of all 3 of these, and it's the largest number possible? So I can divide 5 out of each of these. So I'm going to write a 5 up front. And then I look at my variables. Can I pull a variable out of each of the terms? No, I cannot. I can't pull a variable out of each of the terms because this term right here does not have an x on it. So I cannot pull any x's out because they are not common between all 3 terms. So now if I divide that 5 out of each term, 5x squared divided by 5 is x squared, plus 15x divided by 5 is 3x, plus 10 divided by 5 is 2. And there's your solution. Let's jump over here to example B now. I have 7x to the 6th y to the 5th plus 7x to the 5th y squared minus 21x cubed y squared. Focus on the numbers first. I have 7, 7, and 21. What is the largest number that I can divide evenly out of each of those numbers? 7 is the largest. I can take 7 out of 7 and 7 out of 7, and 21 is divisible by 7 as well. So I'm going to write 7 up here. Now I want to look at the x's and the y's, but do each one of them separately. I have x to the 6th, x to the 5th, and x to the 3rd. The shortcut is to just look at the smallest exponent, and that's what you're going to pull out. But I want you to remember, x to the 6th means x times x times x times x times x times x. X times itself 6 times. X to the 5th means x times itself 5 times, and x to the 3rd means x times itself 3 times. So how many x's do they have the same among themselves? X to the 3rd. So I'm going to pull an x to the 3rd out, and then I'm going to look at the y's as well. So I've got y to the 5th, y squared, and y squared. How many do those have in common? They have y squared in common. So now this is my GCF. I'm going to divide this GCF out of each of these terms. So take your numbers and divide. 7 divided by 7 is 1. I'll put the 1 there even though you don't have to, but just so you can see it. Okay, x to the 6th divided by x to the 3rd. You subtract exponents when dividing, so this is going to be x to the 3rd. Y to the 5th divided by y to the 2nd. 5 minus 2 gets you 3, so this is going to be y to the 3rd. Now I'm putting my plus sign in. I got that plus sign from right here. 7 divided by 7 is 1. X to the 5th divided by x cubed is x squared. And then y squared divided by y squared is 1. They cancel each other out. I don't need to write that 1 again because I have a 1 right here. So, and this is just multiplication. That would be a form, like an invisible form of 1 right there. And then I put my minus sign, and now because of this one, and now I'm dividing this one out. 21 divided by 7 is 3. X cubed divided by x cubed, they cancel each other out. Y squared divided by y squared, they cancel each other out. Here is my solution. Okay, going on to example F. I have 3x to the 5th plus 9x to the 4th plus 23x to the 3rd. Okay, looking at your numbers first, 3, 9, and 23. we do not have any factors that are common between all three of these expressions. 3 and 9 do have a 3 in common, but 23 doesn't work for that. I believe 23 is prime. So I cannot divide something out of these. So now I'm going to go to the variables. X to the 5th, x to the 4th, and x to the 3rd. How many x's could I pull out of each term to where I pulled the same amount out of each term? I can pull x to the 3rd out because this one has an x to the 3rd, this one has enough for x to the 3rd, and this one has enough for x to the 3rd. It's going to have x to the 2nd left over, but it still has x to the 3rd in it. So I'm going to pull x to the 3rd out and then just start dividing. If you want, you can put your invisible 1 up front if that helps you. So 3 divided by 1 is 3. X to the 5th divided by x to the 3rd is x squared. Okay, plus 9 divided by 1 is 9. X to the 4th divided by x cubed is x. And then 23 divided by 1 is 23. X to the 3rd divided by x to the 3rd cancels each other out. So here is your solution. All right, looking at example or problem C now. Here, this is leading with a negative, so I will say this is just kind of a general rule in math. We don't like to lead with a negative, but this is also not in descending order. So let's put this in a better order for us real fast. I'm going to say 28x to the 4th minus 8x squared plus 12x squared y. All I did was change the order of these guys, and now my biggest exponent is leading. And this will be easier for us to factor now. So I'm asking myself, what can I pull out of 28, 8, and 12? I know that they're all even, so I can at least pull a 2 out. But I can pull even more than that out. I can pull a 4 out because 28 is divisible by 4, 8 is divisible by 4, and 12 is divisible by 4. So I'm going to pull a 4 out. Then I'm going to look at my x's. This one has x to the 4th, this one has x squared, and this one has x squared. How many do each term have in common? They have x squared in common. And finally, looking at y's, this last one has a y, but this term and this term, they don't have any y's in the expression. So I cannot pull a y out because it is not common between all three parts. So now I'm dividing 4x squared out, and let's do that. If I take 4x squared out, 28x to the 4th, and I'm dividing it by 4x squared. So 28 divided by 4 is 7. X to the 4th divided by x squared is x squared. I took that 4 minus 2. When I divide, I subtract exponents. Then I put my minus sign. Okay, 8 divided by 4 is 2. X squared divided by x squared cancels each other out. I don't gotta write it. And finally, I have plus 12 divided by 4 is 3. X squared divided by x squared cancels each other out. And then I have y. It's not being divided by anything other than 1. So I got to tack that y on there because it has not been factored out. All right. Moving on to example G. I have 2x to the 4th plus 4x cubed plus 6x squared plus 8x. Looking at your numbers first, I've got 2, 4, 6, and 8. What is the largest number that I can divide out of each of these terms? I can divide a 2 out. I should be more specific. Largest number I can divide out of each of those terms and still have a whole number remaining. So I can pull a 2 out. Then looking at the x's, I have x to the 4th, x to the 3rd, x squared, and x. How many x's do each of these have in common? In other words, if I took an x out of each of them, how many times could I do that? I can only do that one time. I can pull an x out of each of them one time. So I'm going to pull x out because once I pull an x out of 8x, it has run out of x's. And then these others still have a surplus, but this one has run out. So it's not common after the x. So now I'm just going to divide each term by this 2x. 2x to the 4th divided by 2x is, if you need to write the 1, like 2 divided by 2 is 1, then you can. X to the 4th divided by x is x to the 3rd. Now I'm writing my plus sign. 4 divided by 2 is 2. x to the third divided by x is x squared. X to the third divided by x, if you need to, you can write your invisible 1, and 3 minus 1 gets you that 2. When dividing, subtract exponents. Okay, that's just a reminder for your rule. Keep going. So I've got 6 divided by 2, which is 3, x squared divided by x, which is x, and then 8x divided by 2x, that's just going to be plus 4, because 8 divided by 2 is 4, and x divided by x is 1, and I don't need to write that invisible 1. And there is my solution for this one. Finally, I have example D. And in example D, we have another kind of special little scenario where we're going to want to rewrite this. Notice I have like terms. I have negative 6x squared and negative 12x squared. I want to go ahead and combine those ahead of time to make life easier. So I'm going to write this negative 18x cubed first, because it's going to have the highest exponent, and I want to write this in descending order. And now I'm going to combine negative 6x squared minus 12x squared. That is going to get me minus 18x squared. The reason the x squared stayed the same is because I was subtracting. So exponents don't change when adding and subtracting. You apply those rules of exponents when multiplying and dividing, like, you know, you add the exponents or something like that. But in this case, all we did was combine like terms, so we left the exponents alone. Okay, now I have this simplified down. I'm looking for the largest number that I can divide out of both of these. And notice how the leading coefficient is negative. We don't like for that leading coefficient to be negative, so I'm going to pull a negative out. And what can be divided out of 18 and 18? Well, 18. Then I have x to the third and x to the second. What can be pulled out of both of those simultaneously? X to the second. And now let's divide that out. Negative 18 divided by negative 18 is positive 1. X to the third divided by x squared is just x. And then I've got negative 18 divided by negative 18, which is still positive 1. And then x squared divided by x squared is just 1. And so there we go. That's all for today's section of notes. I hope you have a great night, and I'll see you later.